Hi everyone, my name's Kirsten and I'm a Brock teacher candidate with math as my first teachable. The math proficiency tests are coming up, which I know can be stressful for non-math teachers, so I thought it might be helpful to have somebody walk through the sample questions that are online with you and kind of explain the math that's being done. I screen recorded myself going through each of the questions with some commentary on the math that's required, so I hope that's helpful for you. It's a bit of a long video, so I'm going to try and comment below the timestamps for each question so that if you're just looking for help on one, you can find that pretty easily. But if you just want to go through all the whole test with me, then that's great as well. So let's get into it.
Okay, so the first thing to do is open the Math Proficiency Test website and make sure that you're in the section for test applicants. Then in the Learn More section, number 3, go to Preparing for the Test. Then we can go to Sample Questions and Resources, Sample Questions, and then this just tells you some information that you can read later about the sample questions and what type of content there's going to be in each section, and open the sample questions. Okay, so this is question 1. This section, there's 3 questions and it's the non-calculator section, so we'll just be doing all by hand work for this section. So for the first question, what is 6,905 divided by 34? We can start with a quick estimate. If we round to 6,000 divided by 30, that's a much easier question for us to start with. We know that 6 divided by 3 is 2, and these zeros will cancel each other out, so we have just the 2 zeros that are left, giving us 200. That way we can just ignore options A and B that are 23 because we know that's way too far off. 203 is much closer to our estimate of 200, so we know that the answer has to be either C or D. We can do this 2 ways, either by long division or by guess and check using multiplication. So we'll start with the long division. We have 34 going into 6,905. So the first step here is to see how many times does 34 go into 69. Again, we can use estimation. We know that 30 goes into 60 twice, so we can do 34 times 2 on the side to see if that would be a good option for us. We have 2 times 4 is 8, 2 times 30 is 60, so 2 times 34 is 68, and that is smaller than 69. So we can have here 2 times 34 is 68. Now the next step is to do subtraction. So 69 subtract 68 is 1, and bring down our 0 for the next step. Now how many times does 34 go into 10? Well, 0 times because it's smaller. So we have 0 up here, and for consistency we're doing 0 times 34 is 0. You don't really have to write this step, you could just bring down the 5, but for consistency we're going to write it. 10 minus 0 is 10, and now we can bring down the 5 to make it 105. Again, using estimation, we know that 3 times 30 is 90, that's kind of close to 105, so we'll do 34 times 3 on the side to see what that gives us. 3 times 4 is 12, 3 times 30 is 90. Adding those together, we get 102. So when we have our 3 up here times 34, we get 102. And again, we do subtraction and we have 3 remaining. Now we've got to the end here, so this 3 is now our remainder. And we can see that option C is 203 remainder 3. So that's our final answer. Now, if you don't want to do long division, because this is multiple choice, you can do a guess and check. So we'll do that next. Instead of doing the division, we can take an answer that we think is right, multiply it by 34, and see what we get. So we'll take 203 and multiply it by 34. So remember when you're doing multiplication with large numbers to make sure you're keeping everything in the right place value. So 3 times 4 is 12. 3 times 0 4 times 0 is 0. 4 times 200 is 800. So make sure that you're keeping this as 800 and not 80 or 8. Okay, so now we'll move to the 30. 30 times 3 is 90. 30 times 0 is 0. And 30 times 200 is 6,000. And again, we have 3 zeros because 30 has 1 0 and 200 has 2 zeros, so 3 zeros in total to make sure we keep that place value. Now we can add them together. We have 2. 9 plus 1 is 10, so we carry this 1. And 8 plus 1 is 9 and 6,000. So we have 6,902, and remember what we're trying to get is 6,905. So what you'll notice is that there's only a difference of plus 3. That 3 is the remainder, not 0.3. If we took 0.3 of 30, so about 30% of 30 is around 10, that would be if we were adding about 10, if we were looking for 6,912. But just this 3 is the remainder 3. So again, we know that the answer is 203, remainder 3, because of this 3 that we had to add to get the total that we were looking for. So that's the way you can do it with guess and check, just because it is a multiple choice problem. Okay, so we'll select C and go to the next question. What is the sum of the following numbers? So this one's pretty simple addition. The most important thing is to just keep your place value in the right spot. So we can start with the first one, 0.02. And the next one is 0.6. So you want to keep the decimals lined up in order here. Make sure you're not writing your 06 here, because the decimal point is what needs to be lined up. Okay, so we have 0.6. If you want to line up the columns easily, you can add another 0 here, but that doesn't really make a difference. 0.735 and 0.0005. Again, if you want, you can add zeros here to make sure that you have all of your columns lined up and you don't accidentally add these two together. Just whatever helps you best. Okay, so we can add those up. There's just a 5 in this column, 5 in this column, 2 plus 3 is 5, and 6 plus 7 is 13. So we add the decimal, again, still in line with all the decimals that we had when we added them up, and we get our answer of 1.3555, and that's answer B. That's a pretty simple one. Okay, next question. What is 17.86 divided by 0.19? Okay, so the decimals might throw you off here, but a trick that you can use is to just get rid of the decimals. So 17.86 divided by 0.19, that's how we would write it as a fraction, right? If we multiply the top by 100 and the bottom by 100, that's like multiplying by 100 over 100, which is essentially 1. We can multiply everything by 1, it doesn't make a difference. But it's helpful because then we get 1,786 divided by 19. We can forget about the decimals, the answer is going to be the same no matter what, because again, this multiplication that we're doing doesn't change the problem. So how many times does 19 go into 1,786? Okay, how many times does 19 go into 17? 0 times, so we're going to have to go to 178. And again, we can use estimation. Since 19 is pretty close to 20 and 178 is close to 180, that would be 20 times 9. I'll write that on the side. 20 times 9 is equal to 180. But we want to know what's 19 times 9. And since that's only one group less, it's only going to be 9 less, so 171. If that estimation doesn't make sense, you can just do some guess and check on the side. 19 times 9, like we did before, 9 times 9 is 81, and 9 times 10 is 90. That gives us 1 in this column, and 8 plus 9 is 17, still 171. I just like to use this estimation form because I find it a little bit quicker. Anyways, what we want to do then is multiply by 9 and keep it in this column because that's the place value that we were doing, right? Going over 178 instead of putting it in this place. Okay, so we know that's 171. We can do our subtraction. We're left with 7, and we can bring down the 6. How many times does 19 go into 76? Again, I like to use estimation with 20. 20 would go into 84 times. 20 times 4 is 80, which means 19 times 4 is going to be 76. Again, because it's just one less groups of 4, so we subtract 4 from 80 to get 76. That's very convenient here, because then we get 0. And again, that was a 4. So that makes our final answer 94. And that is one of the answers. And so we know that that's correct. So that's all of section 1. And then we can start on section 2. In this section, we can use a calculator if necessary. Okay, so this first problem, 17 minus 2 times 3 plus 9. This is a BEDMAS problem. So if you remember learning BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. That tells us what order we need to do them in, although it is a little bit tricky because these ones can switch, and addition and subtraction could also switch. It just depends on what order they appear in the problem. But there is no brackets in this problem, there's no exponents, so we know we need to do division or multiplication first, which we do have. So we leave the 17, and we're doing 2 times 3. That gives us 6, and we have minus 6 plus 9. Now this is where it might be a little bit tricky because subtraction does come second in BEDMAS, but it doesn't matter because we have to do it in order. So if we do it in order, we first do 17 minus 6 is 11 plus 9. That gives us the final answer of 20. Now it might be tempting to do 6 plus 9 first, but that would actually give you the wrong answer. I'll write it out. If you did 17 minus 6 plus 9, which is 15, then you would get 2 as your final answer. That's actually not correct because what you're essentially doing is adding brackets around the 6 plus 9, which we don't want to do because then this subtraction actually gets put onto the 9 and we have minus 9. What you can do is rearrange if that's helpful. Instead of just doing the 17 minus 6, you could rearrange it to be 17 plus 9 minus 6 and do the addition first then. That doesn't change it because you'll have 17 plus 9 equals 26 minus 6, and again that's 20. A helpful way to think about this negative 6 though is to think about it as 17 plus negative 6 plus 9, right? Subtraction is just adding a negative number. Then you can do these two, 6 and 9, added together first because it's a negative 6. Then you'll have 17 plus 3, right? Because it's negative 6 plus 9. And again, that gives you 20. So just make sure that when you're doing BEDMAS, follow it in order or put brackets around negative numbers if you find that method helpful. So our answer is 20. We can select that and move to question number 2. So this question is asking which option shows 3 to the power of 11 times 3 to the power of 2 as a single power. Okay, so this was just exponent rules. When you have the same base, which is 3 in this case, the base is whatever the exponent is acting on, you can just add the exponents. So that's equal to 3 to the power of 11 plus 2, and that's 3 to the power of 13, which is option A here. Remember, it's not the 9 options because we're not multiplying 3 times 3, we're just simplifying the exponents. And you can learn about other exponent rules online if that's something you need to review. Option B says 3 to the power of 22. That would be if you were multiplying the exponents, but the rule is that when the bases are multiplied, the exponents are added. Another way you can think about this one is 3 to the power of 11 times 3 times 3, right? Because we know that 3 to the power of 2 is actually 3 times 3. But the way that we figure out what exponent is how many times the base is multiplied by itself, right? If we had 2 times 2 times 2, that would be equal to 2 to the power of 3 because we have 3 2's, right? So in this case, we have 11 3's plus another 3 plus another 3. So in total, we have 13 3's. So that's why it's to the power of 13. Okay, question 3. What is 19 thousandths plus 7 tenths? So again, this is a place value question. We have 19 thousandths, thousands is 3 zeros, and 7 tens. Tens is 1 0. Add those together, 0, 7, 0, 9, and 1. Okay, so we have option B as the correct answer. Okay, we get a word problem, fun. Liam has, I like to write out the numbers that we have, $960 in his bank account. Then he spends $123 on a textbook, $55 on groceries, and $800 on rent. At the end of the week, he deposits a check for $260. What is the balance of his account at the end of the week? Okay, so what we need to notice is this is money that's going out of his bank account because he's spending it. This is money that's going into his bank account. And the money that he already has is positive money as well. Okay, so we're essentially adding all of these together. We can add the positives ones first. And then we can also add the negative ones, everything that's coming out of his bank account. Six plus 6 is 12, so you carry the 1. 9 plus 1 is 10, plus you have an extra 2, so that's 12. Sorry, this is addition, not subtraction. And 3 plus 5 is 8, 2 plus 5 is 7, and 1 plus 8 is 9. So now we know this is the negative money, this is the positive money. So we can subtract the negative money from the positive money. And this one you can use a calculator on if you would like, because we are in that section of the test. So that's 242. Again, subtraction, I always forget to write those symbols. Okay, so that's how much money he has at the end of the week in his bank account. We see that's option B. So this one, just based on the word problem, you have to make sure which is the money that's going into his account and which going out to know what to add and subtract. Question 5. Which option best describes the sum of 11 over 5 plus 1 over 7? So this is an estimation problem. They don't want you to give an exact answer. So your options are 1, 2, between 1 and 2, or between 2 and 3. You could do this with estimation, or you could actually add them up and see what you get. The first thing I notice here is that 11 over 5, that's very close to 10 over 5, which would be equal to 2. So we already know the answer is higher than 2 because 11 over 5 is higher than 2, and we're just adding more to it. So automatically I would select D, between 2 and 3, but we can do the math just to check. So when you're adding fractions, you need to have the same denominator. That means the same number on the bottom. So what we're going to do is multiply the top and bottom of this one by 7 and the top and bottom of this one by 5. And you'll see that gives us 77 over 35 plus 5 over 35. Because the bottoms are multiplied essentially by the same, we get the same answer on the bottom. And then we can add up the tops together. So 77 plus 5 is 82 over 35. And you can plug that into your calculator. 82 divided by 35 is 2.3 rounded. So still I would answer between 2 and 3 for this question. Now you don't have to do quite as much handwork as I did there. If you have a calculator that allows you to enter fractions, you could just enter 11 over 5 plus 1 over 7 right from the beginning. Or you could do 11 divided by 5. Get that as a decimal point is 2.2 plus 1 divided by 7 is 0.14. And then you could add those together to get 2.3 approximately. Again, it just depends what you're more comfortable with, if you want to do the handwork or if you just want to directly use your calculator. I would suggest being familiar with what your calculator is able to do, whether it can do fractions or not, before you start taking the test so that you know what method is going to work best for you. Okay, question 6. Which fraction is an equivalent representation of 8%? Okay, so what we want to remember about percents is that they're out of 100. So that's equal to 8 over 100. Right? If you had a test that you got 8% on, you would have only got an equivalent of 8 questions right over 100. I hope that never happened to you, but that is what it would be like. Okay, but now we want to simplify because this is not one of the answers that's given in one of the multiple choice options. So we can divide the top and the bottom by an equivalent number. We could start dividing it just by 2 if that was the easiest thing. We noticed they were both even, but we also know that 8 and 100 are both divisible by 4. So we can do that, divide the top and the bottom by 4 to give us 2 over 25. And that is one of the options, option A. So that one's just about simplifying fractions and understanding what a percentage is. Question 7. The cost of 5 avocados is $3.70. What is the cost per avocado? Okay, so I'm going to use AV for avocado. So we want to know what is the dollars per avocado. And this per means division. So that's what we need to do in order to get to the answer. So we have our dollars, 370, divided by 5 avocados. And you can do that on your calculator. 3.7 divided by 5 gives you 0.74, and our units are dollars per avocado, like we are looking for. So 74 cents per avocado is option A. Question 8. An amusement park charges an entrance fee and cost per ride shown in the table, which is rides and total cost, 3 and 9, 15 and 27. And we want to know what is the cost per ride. Okay, so what you want to notice here is that if you just did division of $15 per 3 rides, you would get $5 per ride on this one, but 27 divided by 9 is only 3. So those would be different cost per ride. So that tells us that there's some fixed cost, which is the entrance fee as it was told in the question. So we can't just use division because we'll get either 5 or 3, which is options B and C, but that's not actually the right answer. So what we need to do is find the difference to find the slope of this linear problem. Okay, so the difference between 15 and 27 is 12, and the difference between 3 and 9 is 6. So then we can use these $12 and the 6 rides to get that it's $2 per ride. And then we know that there would also be an entrance fee, which if you want to go backwards from 3 rides, you can subtract the $3 per ride, which would be 6, to know that your entrance fee is $9. But again, that doesn't really matter for this question. All that we wanted to know was that it's $2 per ride. So that's option A. Okay, question 9. Another question about fractions. Which list of 4 fractions is in order from least to greatest? So let's just look at option A to see what the fractions we're looking at are. 3 over 7, 3 over 14, 3 over 10, and 3 over 20. Okay, so what we want to know about fractions here is that the closer the denominator, which is the bottom, and the numerator, which is the top, are to each other, the closer they are to 1. Right, for example, if we had 3 over 3, that's division. 3 divided by 3 is equal to 1. Whereas if we have 3 over 4, let's say, that's the numerator, so on top is smaller than the denominator. So that's going to be 0.75, smaller than 1. Or if we had 3 over 2, now 3 is bigger on the top than the bottom, and that's going to be 1.5, so bigger than 1. So essentially, the farther apart they are, the farther apart they are from 1. So in this case, 3 is smaller than all of the denominators. So 7 and 3 are fairly close, closer than 3 and 14. Since those are a farther gap than 3 and 7, we know that 3 over 14 is smaller. So since we're looking to order from least to greatest, we should move the 3 over 14 over. But let's look at the rest. 3 over 10, also smaller than 3 over 7, but not smaller than 3 over 14. So it should go between these two. And 3 over 20, 20 is the farthest from 3, so it's going to be the smallest. So when we reorder, we should have 3 over 20, 3 over 14, 3 over 10, and 3 over 7. Now if you wanted to do it another way, Since we know that fractions are division, you could just put all of these in decimal form. So 3 divided by 7 is approximately 0.43. 3 over 14 is approximately 0.21. 3 over 10 is 0.3. And 3 over 20 is 0.15. And so you can order them that way. You can put a 0 on the 3 if that helps you to know that it's more like a 30 than just 3. But essentially, the answer is still going to be the same. So we can choose D and move on to the next question. Okay, question 10. We're getting through these. I hope you guys are following along well and understanding everything. If you're not understanding any specific question, you can comment below and I'll try and get back to any questions as soon as I can, or anybody else who's watching the video. You can answer each other's questions in the comments. That would be helpful. If you do have a question, try and put the tag for what time you're looking at so that it's easy for me to find what you're wondering about. Okay, question 10 though. Last year Diana sold 800 necklaces. This year she sold 1,080. And what is the percentage increase of necklaces that she sold? So percentage increase, we want to know that keyword increase. She increased her sales by 280 necklaces. That's how much she increased by, right? To get from 800 to 1,080. And then to find the percentage, we're finding the percentage increase from the first year, from the 800 necklaces, not from the necklaces that she sold now. So we want to do a division, 280 over 800 to get a percentage. We have to multiply by 100%. So you can do that on your calculator. 280 divided by 800 is equal to 0.35 times 100% is equal to 35%. So she had a 35% increase from the first year. Okay, question 11. A rectangle is cut into fourths. Each fourth is cut into 4 equal parts. What fraction of the rectangles are the resulting parts? Okay, so let's draw a diagram for this one. We have a rectangle. We're dividing this into 4 parts. Then each fourth is cut again into 4 equal parts. So what fraction of the rectangle is resulting? We can just count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 parts. So we know that it is 16ths. That is the resulting parts. That's option D. You could also do this using multiplication. We have cut into 4 pieces, and then each of those 4 is 4 more pieces, so that's multiplication grouping is equal to 16. Whatever way is easier for you to think about it, both work and you get the answer 16ths. So question 12. Chris earns 80% of $175. So this is just a simple problem. What you want to know is that this word of actually would translate to multiplication. Okay, so 80%, how we multiply percentages is by putting it into a decimal. So 80% would be changed into 0.80 times 175. And you can do that on your calculator to give you $140 is the original unit, and that's option C. So we'll go to the next question. Question 13. 100 kilometers in 3 hours, 40 kilometers left. If she travels at the same speed, how much longer will it take her to get to the destination? Okay, so we want to know what that speed that she's traveling at is. And our speed is going to be in kilometers per hour. And again, this per is going to mean division. So she's done 100 kilometers in 3 hours. So her average speed is going to be 33.3 repeating kilometers per hour. Now she has 40 kilometers left to go, and she's going to keep traveling at the same speed. How much time will it take her to get to the destination? So here we want the units to cancel out. We want kilometers and kilometers to cancel, so that all we're left with is hours, because that's the answer unit. So in order to get them to cancel out, we need to do division. So 40 kilometers divided by 33.3 kilometers per hour. And these kilometer units are going to cancel out, and the hours comes to the top, just what we wanted. So we'll have 40 divided by 33.3 is 1.2 hours. And that's option B. And question 14. Which fraction is between 3 over 8 and 4 over 8? Okay, and our options are 3 over 9, 8 over 15, 11 over 24, or 15 over 28. So there's a couple ways that we can think about this problem. We can first just use logic, what we know about fractions, to try and eliminate some of these options. So if you remember what we talked about before, since we had 3 over 8 and 3 over 9, we have the same numerator. We can compare those ones fairly easily. 3 over 8 is closer to 1 than 3 over 9, because 3 over 8 are closer together than 3 and 9 are together, which means that 3 over 9 is smaller than 3 over 8. So if this were a number line, 3 over 9 would go on this side, whereas we want something in between. So using that, we can say 3 over 9 is not the right answer. 8 over 15. So another way we can do this is say, well, we know that 4 over 8 is 1/2, but 8 is slightly bigger than a half of 15, right? Because 7.5 is half of 15, so 8 is slightly bigger. On the number line, 8 over 15 would be slightly bigger, and again, that means it can't be in the middle. 11 over 24. This one's a little bit trickier. You can think about it again in terms of a half. So half of 24 would be 12. So it is on this side of 4 over 8. But then we want to know which side of 3 over 8 is it on. So we can multiply and get 24 on the bottom of this one if we multiply by 3. Right, 3 times 8 is 24, and then we would get 9 over 24 just by doing the multiplication of 3 and 3 on that one. So 11 over 24 is bigger than 9 over 24, which means it would be on this side of 3 over 8. So there we found our answer, but we can just look at the last one anyways, just to see how we would figure it out. So this one's pretty much the same as 8 over 15. We know that 14 is half of 28. So 15 is bigger, and it would be on this side of the 4 over 8. And so that's how we could figure out that that one was wrong as well. Again, just like last time, if you found it easier, you could just substitute these all into decimals using your calculator. 3 divided by 9 is 0.33. Repeating, 8 divided by 15 is 0.53. 11 divided by 24 is 0.46. And 15 divided by 28 is 0.54. And then you could do the same thing with the 3 over 8 is 0.38, and 4 over 8 is 0.5. That way you can easily notice that this is the only one that's between. So again, 11 over 24 is still the only correct answer. Whichever way suits you better, you can use on the test. The first way might be a bit quicker if you are comfortable with it, but you might feel that it is more secure to just do all the translating into decimals, and that's fine. Okay, question 15. Okay, so Roz and Sam are making sandwiches. Whenever Roz makes 5, Sam makes 4, and together they make 72. Okay, so we can use two equations to solve this problem. We can use variables r for the number that Roz makes, and s for the number that Sam makes. And we know that they make 72 in total. So our first equation is going to be the number that Roz makes plus the number that Sam makes is equal to the total number. Now our second equation has to do with how quickly they are making the sandwiches. So we can see that every time Roz makes 5, Sam makes 4. So our equation is going to be that Roz makes 5 over 4 times the number Sam makes. We know that he's going to make slightly more because every time he makes 5, Sam only makes 4. 5 over 4 is greater than 1, which means that the number Roz makes is going to be slightly bigger than the number that Sam makes. So that's where we get that second equation. Now, since the question is asking us for how many Sam makes, we want to substitute this equation into the first equation so that the only variable we have left is the number that Sam makes. So instead of r, we're going to write 5 over 4s plus s is equal to 72. Okay, and then we can simplify that by creating another fraction, 5 over 4s plus 4 over 4s, because remember here there's actually a little invisible 1, still equal to 72 in total. So now we have 5 plus 4 on the top and 4 on the bottom, still equal to 72. So we want to get this s on its own, so we can multiply by 4 to cancel out the denominator of that fraction. These ones are going to cancel out, and you can do 72 times 4 on your calculator. So we still have 9s is equal to 288. And then to get rid of that 9, we divide. Again, these 9s then cancel out, and you can do 288 divided by 9 on your calculator. And you get s is equal to 32. Okay, now if you remember our first equation, if we put this 32 back into this equation, we would have the number Roz makes plus 32 is equal to 72. You can easily see there that the number Roz makes is 40. And that makes sense because he's making slightly more than Sam is making. So we can check our answer that way, and our answer is going to be 32. So question 16. Here we have a grid about 4 stores hiring people to deliver flyers for different amounts per flyer delivered, and the total pay on the y-axis and the number of flyers on the x-axis. And we want to know which store will pay $45 for 450 flyers delivered. So what we need to do here is figure out how much each store is paying per flyer delivered. So again, with this question, we can automatically eliminate some of the possible answers. So we see that store X, their data point shows for $45 for the total pay, but it's only for 250 flyers delivered. So that's not going to be the answer we're looking for because we're looking for 450 flyers delivered. Similarly, store Y, the data point shows for 450 flyers delivered, which is what we're looking for, but their total pay is only $30. So that's not the answer we're looking for either. So we really only need to compare store W and store Z. So store W, we can do their total pay is $15 for 150 flyers. Store Z has $65 for 600 flyers delivered. And what we're looking for is $45 for 450 delivered. Now the easiest thing to do is just to simplify these down by using division. So 15 divided by 150, 0.1. So you're getting 10 cents per flyer. And 65 divided by 600 is 0.11 approximately. And again, what we're looking for, 45 divided by 450, is 0.1. So since these are paying the same per flyer, we know that store W would pay you $45 to deliver 450 flyers. So that's the correct answer. Okay, question 17. We're almost done the math questions. You can do it. Keep going. A rectangular window measures 4 meters wide and 3 meters high. What is the length of the window's diagonal? Okay, so we have our window that's 4 meters high and 3 meters wide. And what we want to know is this diagonal. What is the length of this diagonal? So we're going to use Pythagorean theorem to figure this one out, because we can see that this is a right angle triangle. So Pythagorean's theorem says a squared plus b squared is equal to c squared. And what that means is that if a is the length of one side, b is the length of the other, then c is the length of the hypotenuse or the diagonal that we're looking for. So in this case, we have 4 squared plus 3 squared is equal to c squared. So we know that 4 squared is 16, 3 squared is 9. That's going to give us c squared. We can add those together to get 25 is equal to c squared. Now to get rid of that squared, we're going to take a square root because that's the opposite operation. So we get 5 is equal to c. If you didn't know what to do with the square root, you can just think to yourself what number times itself, because that's what a square is, would give me 25. And we know that 5 times 5 is 25. So our diagonal is 5 meters across. And be careful, option A here is 25, but that's the answer if we had not gotten rid of this square. So just be careful of that. Question 18. The parallelogram below will be cut into 2 congruent triangles. What is the area of each triangle? Okay, so again we can use a diagram for this one. Now, if you didn't notice this before, there is a calculator on the app. There's also these books which will give you all different formulas that you may need. So the one that we want to know here is the area. So it tells us here that the area of a parallelogram is base times height, where the base is this bottom length and the height is on a right angle from the top to bottom, not the angled side. So in our diagram, we have the base is 12 and the height is 11. We don't need that 15 right now. So we can use that formula, area equals base times height, 11 times 12. You can do that on your calculator if you need to get 132 meters squared, because it is an area. This is meters times meters will give us meters squared. But the question is asking if it's cut into two congruent triangles. So the key word here is congruent. That means same. So for example, if we cut this parallelogram in half this way, that would be two triangles that are the same. Essentially, each of them would have half the area of the total parallelogram. So we need to know what is half the area of the total parallelogram. So we can multiply by 1 over 2, or the same thing as dividing by 2. And again, you can do that on a calculator if you need, to get 66 meters squared. And that's option A. Again, be careful, 132 is an option, but we need to know that it's two congruent triangles. We're only looking for the area of one. So the next question. Which of the following dimensions produces a rectangle with the smallest perimeter? So again, we can go to the formula sheets if you need to look at a rectangle. What is the formula for the perimeter? And it is 2 times length plus width in brackets. So you could just try out every single option that you're given. So option A is 2 times 10 plus 120. And remember, you're doing what's in the brackets first. So that's 2 times 130, which will give you 260. B is 2 times 30 plus 40. So that's 2 times 70, 140. You can do this all on your calculator. I'm just going to write it out anyways. 2 times 50 plus 24 is going to be 2 times 74, which will be 148. Or our last option, 2 times 60 plus 40 is equal to 200. So then by comparing all of these, we see that 140 is the lowest answer. So that would be the smallest perimeter, and we can check B as our answer. Last question. 5 boxes create a rectangular prism below. Each box is 9 by 9 by 9. What is the total surface area of the rectangular prism? Okay, so we can do this two ways. First, we could consider what is the surface area of one of the cubes. Again, we can go to our formula sheet. We see that the area is going to be 2 times width times height plus length times width plus length times height. So we know that our length, width, and height are all 9. So we can substitute that in to get 2 times 81 plus 81 plus 81, since that's 9 times 9. And again, you can do this on your calculator. 81 plus 81 plus 81 is 243 times 2 equals 486. So that's our total surface area. If one cube was on its own. But we have 5 cubes, so we can multiply our surface area by 5. That's 2,430. But since the rectangles are touching each other, there's actually some surfaces that we lose. So this cube loses one surface because it's touching another. The second cube loses 2 because it's touching 2. Third loses 2, fourth loses 2, and the fifth loses 1. So in total, how many faces have we lost? 8 faces lost. And each of those faces has a 9 by 9 surface area. So we can do 8 times 81 is 648 that we need to subtract from our total area, right? Because those aren't being counted once all of the cubes are together. So we can do 2,430 subtract 648, and that gives us 1,782. And that's going to be in centimeters squared because it is area. Another way we can do this is think about this prism as one rectangle rather than 5 cubes. Since we know that it's 5 together, this side, we can call it the length, is going to be 5 times 9 is 45 centimeters, while the width here is still going to be 9, and the height is still going to be 9. Now we can use the surface area from before. 2 times width times length plus width times height plus height times length. I'm not sure if I said that in the same order, but because it's addition, it doesn't really matter. So you can multiply those together using your calculator. 9 times 485 is 405. Once you've done the multiplication, you can add them together. That's 891 times 2 is 1,782 centimeters squared. And you can see that's the same thing we got before, just a different method. Whatever one makes more sense to you is the one that you can use. So that's option C. And that's the last question. So we can click review and submit. So now is the one that's not about math skills necessarily, but how to assess math. This is all based on growing success. So based on assessment and evaluation of a student achievement, what does a level 4 identify? Provincial standard, surpasses, approaches, or falls below. So level 4 is the highest. It surpasses the provincial standard. Assessment that occurs before a period of learning to assess a student's readiness for learning and learning preferences would be considered which of the following? Of, as, for, or of learning skills. So this would be assessment for learning, something that a teacher would do so that they can teach better and help the students learn better. It's not assessing what they have learned, but something that will be used for future learning. And what does not change for a student receiving accommodation? So teaching strategies might change, time for tests might change, environments might change, but curriculum expectations don't change, otherwise it would be a modification. Making connections within and between various concepts and contexts is an application. That's just directly from Growing Success again. What type of gap between a student's actual achievement and his potential achievement? So that type of gap is a learning gap. That's the only type of gap that's mentioned in Growing Success. And lastly, which of these strategies for differentiation would likely be the most effective in a mathematics class? Groups that never change probably isn't the best, because then you don't get a chance to learn from different peers. Teaching only whole class, the same thing, you don't get to learn from different peers. Providing manipulatives for the same students. I'm not sure exactly what it means by the same students, but everybody should have the chance to use manipulatives when possible. So I would choose D, providing alternative instructional and assessment activities for students. So once you're sure you want to submit the test, you can press OK, and then it will show you all of the questions that you got right and or wrong. If you got it wrong, it'll just show you a little X. You can click any of the questions and it will show you the correct answer and the answer that you selected. So you can review any questions that you had trouble with by doing that. And then if you leave, it doesn't remember your data, so you can retake it again if you want another practice. But I would probably recommend actually looking at questions that you maybe had more difficulty with and looking for other practice, because these questions don't change and the answers don't change, they don't even change order of A, B, C, and D. So I wouldn't do this test over and over, because the questions on the real test are going to be different. But I hope you found that having somebody walk through all of these questions with you gave you a bit more insight into what the questions were asking and how to complete them, and maybe could help you figure out what you needed to learn more about. Again, please comment down below if it was helpful, or if you have any questions that I would be happy to help you with in the comments as much as I can.